So, hello everyone. Let's start with a new fresh topic, which is binary tree. Binary tree. So, what is binary tree? Binary tree is nothing but a tree which are having only two child. Simple. So, in previous video, we talk about tree, how to define a structure of tree. So, let's begin with that part. So how to define a structure of tree? Basically, we have a struct function in which we have a tree node. In tree node, we basically define our two values, which is int data and the two left or right child. Struct star tree node left and right. Struct tree node, it is a pointer right. RIGHT. It is also comes here. So this is our tree structure look like. So we are having basically, so how binary tree gonna look like. Basically, binary tree is a structure which is having our data and two values which are currently pointing to null. Okay, so how our binary tree look like? Binary tree which are having child, which are having two child. So our left child, suppose it is having some data. Our right child, it is also having some data. So it there are only two nodes which are connecting to the parent node, which is also known as our root. It is simply known as root, not parent root. Root, ROOT, root. So the parent of this child is this. So now if we draw furthermore, it have it is having more nodes which are having data. So if it is not pointing to any other nodes, then we will define the left of that node is equal to null and right of that node is equal to null if it is not pointing to any right node. Similarly, if it is pointing to some node, if this node is pointing to some node, then we does not put null here. And if the right we can see the right node is not a right node is empty, so we put here null. Similarly, it is not pointing to any of further nodes, so left node is also equal to null, right node is also equal to null. Simple. It is a binary tree. As we can see, there are at most two child, one child and two child. Simple. So let's talk about how to create a binary tree. So how to create a binary tree? Let's see code. So this is our previous code which we are created for our how to construct a tree in C. So this is the code. Now we can make some changes so that it can work for binary tree as well. So what are those changes? So as let's see what are those changes. So first of all, we have we are defined our tree structure, then how to create nodes, then how to print nodes. This is our tree if we are connecting the tree manually. So let's make it binary tree. So let's define a function void. No, it's gonna return basically what we gonna, yeah, suppose it returns a node, tree node star create, and in this we're gonna take the head of the node, head node. uh, let's suppose it is a head node, and other data is the value of that node is data. After taking head node, first of all we have to check whether our head is equal to null or not. So for that we take uh, we put in if condition. If it is null, then we have to create that node. So head is equal to, we are passing to a function of a create node here with the data. So let's pass the data, and after creating a node we just return head. Okay, simple. If head node is not equal to null, then what we gonna do? So simply, if head node is not null, else if, so we have to check it to the left side of the, if left side is equal to null, then we create a node. No, left side is equal to null, it's not that like. First of all we have to check uh, whether the data of the root node, whether the data of the root node is greater than or lesser than equal to our data. So we have to check that data. If it is smaller than or equal to head node data, head data, so in that case what we gonna do, simply we create a head lab, we go to the head lab part, then create a node, again create node, again create node. In that node we pass head and data. Let's see, it's looks like difficult. We also try, after that we try run this code, how this code work. And in else part, if the data is greater, then we move it to the right, and let's create again head data. Simple. Okay, now after that we return our head. So this is our binary tree code. Look like this is our binary tree, binary tree insertion. So let's see what are the changes. These are the nodes which were created manually. So let's comment this part now. So this is our create node function. It is having a head, we have to pass it head. So what we gonna do, like first of all we create a null node, tree node, which is head equal to null. Okay, simple. After that we take a head node and pass it to, we take our head node which is equal to create, pass it to the create function head and our data. Suppose our data is 10. Okay, so this is simple. Now after that again we create another node which passing to the head, again data will be 11. Suppose let's duplicate this, change the data value. Suppose this is 14 and this is 9. Okay, let's take another node which is 8. Okay, let me do one thing. So after creating the nodes, we after that we pass it to the our friend node function, which is takes head, and we have to comment this part. After creating a node, free our head. Simple. So let's compile this question. So let's run this code. Let me save it first. So let's run this code. GCC. It's not gonna print. So let's recheck it. We create a head node. Yep, head node, return head, whether head data, head left, head right. Why this uh passing to head? Yep, create tree node. Yep, head left, head. Oh yeah, we have to pass. Uh, it is head r right is equal to create. Here we have to pass the left parameter of the head, and here we have to pass right parameter of the head. So let's run it again. Yep, it is parenting. So let's draw this tree. So yep, let's draw this tree. So let's see how this tree gonna look like. So this is our theory part. This is how we take a root node and divide it into two parts. So let's see. First of all, we have a value 10. Actually, we are having a value 10. So we take 10. After that, left value of 10 is 9. Left value of 10 is 9. Okay. And after that, 9 is our head, as this is our pre-order traversal. Pre-order traversal. So we are in this traversal we are taking root node, then left, then right. Okay. So let's talk. Then after that, 9 is our current parent, so 9's left child is 8. After that we comes up and we see that it does not have any root node, right node, so we take it empty. After that we come up and also see that right node is empty. After that we comes to the our current root node. This is our root node, so we see that our root node right's value is 11. Now our current parent is this. Now 11 left, it is empty, and 11 right, it is 12. It is 12. So after that we can see 12 child is our basically it, now it's our parent. Now we can see 12 left is empty and 12 right is occupied by 15. So this is our binary tree gonna look like. So every left node, every nap node, every left node is smaller than its parent. So as we can see, 10, the left node of this is smaller than its parent node. If we take right node as a parent, 9 node as a parent, we can see its left node is always smaller. Okay, so let's see again. Right node, this is our root node. So right node is greater than its parent node. After that, if we can see the right child of this 11th node is always greater. Yeah, it is greater. And if 12, we can see it is already greater. So this is our binary tree implementation in C. Simple. Okay, thank you.